So the first one here, from a decimal going into the fraction, what's that going to become? 65 over 100. Good, because it is tenths and hundredths, and it's that place value of the last digit that gives us the denominator of our fraction. Of course, we're not going to leave it like that. What can we do with it? Careful. We divide by 5 will give us 13/20. You're close. Did you sure you didn't hit 60 by accident? Or the 5 didn't register or something? For the next one, what do we do with the number, the part in front of the decimal point? Worked better this time? Worked better this time?
Yeah, it did.
Okay. What do we do with the part in front of the decimal point? That is our whole number. We really don't do much of anything with it. It's going to be 8 and then some fraction. It's the part after the decimal point that is the fraction. What's that going to become? 384 over 1,000. Again, it is tenths, hundredths, thousandths. That last digit being in the thousandths place gives us our denominator. And we did say that there's a shortcut to double check. 1, 2, 3 decimal places. There better be 1, 2, 3 zeros in that denominator. What can we do with that to reduce it? What's that? Okay, what can they both be divided by? Okay. Well, they're both even. Let's start with that. They can both be divided by 2. Give us 192 over 500. Then what? Okay, they're both still even. So what's that? 96 over 250. And then? Once more? Okay. 48 over 125. That's it?
That's a 128.
Okay.
Try again.
No extra charge for the extra 3. 48 over 125. So 8 and 48 over 125. Okay, so yeah, for those of you that are wondering who's sitting in here, this is Bonnie Copenhaver. I told you guys they're going to come in and just do a focus group. It's kind of like student evaluation, so that it's also an excuse for administration to come in and reconnect with the students.
Yeah.
I know I'd go nuts stuck in an office without my students all day. Yeah. You guys need more time to do the last one, or did everybody get to it? You got to it? Okay. So you tell me where to start. 2 is a whole number, okay? Okay. We're 10,000, good. Tenths, hundredths, thousandths, 10,000. So it's over 10,000. Then what? Yep. Divide by 5. Okay, what do we get? Good.
That again by 5.
Still divisible by 5. So we got 75 over 2,000, and both of those, the 75 ends in a 5, 2,000 ends in a 0, so we can see we can divide both by 5. 75 divided by 5? 15. 2,000 divided by 5? 400. Are we done? Divide by 5 one more time to get 3 over 80. Perfect. So it is 2 and 3/80. Perfect. Okay, so today we're going to keep going with our operations with decimals so that we can go the other direction to go from a fraction into a decimal. Just a quick review. When I add decimals, what do I have to make sure I do? Line up the decimal point. And the reason for that is because I said so. There you go. When we add or subtract, we can only combine things with the same name, and that goes right down to the individual digit. This is ones. We can only combine that with other ones. This is tenths. We can only combine that with other tenths. So lining up that decimal point, is really just making sure we line up things that have the same name or same place value so that we combine things that have the same name. Now before we add here, we should probably fill in a 0, and then we add. 0 plus 6 is 6. 3 plus 9, 12. So 2, carry the 1. Before we can do the next column, we need to drop the decimal. And then 1 and 4 is 5 plus 7, 12. So 2, carry the 1, and 3. So 32.26. On the subtraction side, something like that, we need to line up the decimal point just like we did with addition, but the 9 doesn't have a decimal point in it. It's after it. Any number without a decimal point, the decimal point is at the end. Perfect. So we line up the decimal point. What do we have to do here? Put in the zeros, 1 over each of the digits below it. And we go to subtract. 0 minus 2 can't be done, so we need to. Okay, we go to borrow. Exactly. We can't borrow from here. We have to keep going to the 9. So we borrow. That's 8. And what we're borrowing is giving this, turning that into 10. But we need it down here, so we have to keep going. Borrow again. That's a 9 and a 10. And one more time. 9 and 10. Now we're set to subtract. 10 minus 2, 8. 9 minus 8, 1. 9 minus 5, 4. Bring down the decimal. 8 minus 3 is 5. Perfect. So the next step. When we go to multiply decimals, am I going to have to line up my decimal points? Why not? You say no. Why not? Well, remember, when we multiply, we don't need the same name. Because of that, every digit in the top number can be combined with every digit in the bottom number, just like with whole numbers. So we don't have to line up the decimal points because we're not worried about lining up columns and place values. The hundredths here can combine, or the tenths here can combine with the hundredths here, as well as with just the tenths up there. So remember, our long multiplication is just an organized method. I'm going to rewrite that so it's a little clearer. Just an organized method of making sure every digit in one number gets combined with every digit in the other number. Where do we start? The 6 on the bottom with the 2 on top. Perfect. Which makes 12. So 2, carry the 1. And then 6 times 4 is 24. Plus 1 is, so 5, carry the 2. What do we do with the decimal point? Nothing at this point. Correct. So then what? 6 times 3 is 18. Plus 2 is 20. So 0, carry over the 2. Before we move, before we do the 7, do the 0 or a blank space there, one of the two. I also like to do this so that I don't confuse my carrying. So now what? 7 times 2 is, so 4, carry the 1. 7 times 4 is 28. 29. So 9, carry the 2. Perfect. 7 times 3. Perfect. So 23. Carry the 2. Then what? Okay, we're moving over 2 spots, so 2 zeros here. So 2 times 2 is 4. 2 times 4 is 8. 2 times 3 is 6. Okay, now we're going to add them all up. Good. So 2, 0, and 0. 2, 5, and 4. 9, 0, 9, and 4. 13. So 3, carry the 1. 1, 2, 3, and 8. 14. So 4, carry the 1. 1, 2, and 6. 9. Okay, so the $1 million question. Where's my decimal point go? Okay, between the 4 and the 3. Somebody said 3 places over. Where did the 3 places come from? Okay, how so? Okay. We've always been taught you count after the decimal place in the problem. We have 1, 2, 3 decimal places. So in our answer, we have to start at the end of the number and count back 1, 2, 3 decimal places. Why? We've hinted at this before. Because I said so. Remember, I said that's what we want to get away from, as the teacher says so. This is hundredths up here. This is tenths. And when we multiply, we don't need the same name because we're going to combine the names. Hundredths times tenths is thousandths. So we have to have our decimals going down to the thousandths in our answer. So for you guys to try in your notes. Try that one in your notes quick. Let's see how you do. Well, let's take a look and see how you did here. If you're not quite done, that's okay. You can fill in the rest as we go. So where are we going to start? 4 times 2 is 8. 4 times 3 is 12. 2 carry the 1. Perfect. 4 times 5 is 20, plus 1 is 21. So 1 carry over the 2. And then put a 0. Good. 7 times 2 is 14, so 4 carry the 1.
Well, no, we're just going to let you have that.
Hey. 7 times 2 7 times 3 is 21, plus 1 is 22.
Okay, so 7 times 3 is 21, plus 1 is 22, so 2 carry the 2. And 7 times 5 is 35. Perfect. 7 times 5 is 35, plus 2 is 37, so 7, move over the 3, carry over the 3. We'll add it all up. So we got 8, 6, 3, 9, and 3. Where's my decimal point go? So between the 3 and the 6. Perfect. 1, 2 decimal places in the problem. 1, 2 decimal places in the answer. Now there's another way we can locate that decimal point. Let's go up here once. This is about 3. This is close to 30. 3 times 30 is about how much? 90. So I'm expecting my answer to come out to be close to 90. So in this solution here, it would not make sense to be 9.4, and it would not make sense to be 943. So the only place that decimal point makes sense is between the 4 and the 3. What's that? Yes, exactly. 3.4 is about 3. It's closer to 3 than it is to 4. 27, I try to round them so there's only one digit in front and everything else is zeros. That way you can get a really quick estimate in your head. No, I'm not. There's, I won't get into my opinion of that, but there is some good math behind it. Yeah. So any resemblance I have to that is because there's good math behind some of it. So 53.2 would round to what? 50. 7.4? 7. Now some of you said 53. That's fine. It's just, it's easier if I round it further. So 50 times 7 is about 350. So again, here, the only place that decimal point makes sense is there, 393. 39 wouldn't make sense. 3,000 would not make sense. 393 is the only thing that fits in with our estimate. So you can always go back and double check. We talked about this with whole numbers about, I know you got the calculator and I know you're going to use it, but think in your head a little bit about where you expect that answer to be. That's even more important with decimals because if you miss a key when you're doing whole numbers, it's usually relatively obvious. With decimals, if you miss a key, your calculator could spit out that, and that's not necessarily so obvious. All the digits are actually correct. What happened? Most likely on one of your numbers here, the decimal point didn't register. And it's really easy. Some of your calculators, if you're looking at the display, the decimal point doesn't even show up on the display till you hit the next number. So it's really easy to miss that decimal point. So if I'm thinking first, 50 times 7 is 350, my calculator spits out 3,936. I know there's a red flag right away that I know I better at least punch it in again and make sure that that's right. Of course, if you get the same answer twice in a row, either something went right or you made the same mistake twice. If you get the different answer 2 times, then you know you've got something to check over. Okay, so the next step, let's do some division. Let's do 64.73 divided by 3.8. We've talked about division a lot, about how division is the one operation that has changed the most from what it really is. The shortcuts that we've learned are very, very different from what the process of long division started out as. I'm not going to go back again and show you that whole repeated subtraction algorithm. I'm just going to stick with what I know you guys have seen before at this point. How do we divide by a decimal? We're dividing here by 3.8. How do we do that? Careful. You're a couple steps ahead of us there. We could turn it into a fraction. I don't want to work with that as fractions, though. What we've been taught to do, kind of like with dividing and multiplying with mixed numbers, move the decimal, get rid of it. We've been taught not to divide by decimals. The process you were probably taught was this: take the decimal point, move it to the end of the number we're dividing by. Make that a 38. But in order to make this work out, then we have to do the same on the inside, move it over. We had to move it one spot here. We have to move it one spot over here. So this becomes 647.3 divided by 38. The question is, why can I do that? Don't say because I said so.
Because what you do one side, you have to do the other.
Okay, and that's the right terminology, exactly. When we talked about fractions, we said a fraction is a division problem. Well, division problem can also be thought of as a fraction. We can think of this as 64.73 over 3.8. And if I want to get rid of that decimal point in my denominator, one of my common rules for fractions is I can multiply the numerator and denominator by the same thing. What do I multiply by to get rid of that decimal point? 10. Moves it over. But I have to do the same on top, making this 647.3 over 38. So now our problem has changed, and it's 647.3 divided by 38. Now there's one more piece of information we should have here to make this a fair question. Let's say I want this answer to the nearest thousandth. So let's begin. Like any other division, we're going to start, does 38 go into 6? No, so I leave it blank above the 6. Does 38 go into 64? How many times? 1. So I'm going to put a 1. The 4 was the last digit I used, so I put a 1 above the 4. What's next? Okay, 1 times 38 is 38. We subtract that from 64 to get 26. Very good. Now what? Bring down the 7. And then we're looking at
7 times
38 goes into 267 7 times, you say? So 7 was the last digit we used, so our 7 goes above the 7. 7 times 38. 266. Very good. So we subtract to get 1. Now we can't bring down the 3. Why not? What do we have to do first? Decimal goes straight up. Now we can bring down the 3. Does 38 go into 13? No. So what do we have to do?
0.
Yeah, since it can't go in there, we have to put a 0 above the 3 to account that we've used that 3. Now we're at the end of the number. Does that mean we're done? No. What do? We can add zeros to the end of this, and we'll bring it down. So now it's 38 going into 130. How many times does that work? 3? So 3 times 38 is? Does 114 sound right? Okay. So we're going to subtract. We get what? 16 left over? Now what? Add another 0 and bring it down. 38 into 160. 4 times. That's bugging me to have that 0 a different color. So 4 times 38 is 152. Good. We subtract to get 8. Are we done now since we're at the thousandths digit? What do we have to do? Keep adding zeros. Why? Well, with decimals, a lot of times we're going to be stuck. Not necessarily the remainder, but we're going to be stuck with some leftover information. It won't always come out to an even division. But we do have to add one more 0 and bring it down. 38 goes into 80 how many times? 2 times. The reason we needed one more 0, even though this is already the thousandths place, is we needed to know whether that's going to stay 4 thousandths or if it's going to round up to 5. What's the 2 telling us? It's going to stay 4. So this is 17.034 to the nearest thousandth. What do you think? Easy? I like that answer. Let's do 49.72 divided by 1.9. Let's say I want it to the nearest hundredth. In your notes, calculate that out for me quick. Just to make sure you're on the right track. We know the problem we're going to do here is not really 49.72 divided by 1.9. It's going to be what? Perfect. 497.2 divided by 19. Do you guys need a couple more minutes? We're good to go? Okay, I heard someone say almost done, so I'll give you a few seconds here. Okay, so where are we starting? $19 to 40. First of all, 19 does not go into 4, so we have to leave it blank above the 4. So then 19 into 49 goes 2 times. And then 2 times 19 is 38. Then what?
Then bring down, subtract it and take 11.
Subtract it to get 11.
Bring your 7 down.
Bring down the 7. And then?
6 times 19 is 114.
So 19 goes into 117 6 times. 6 times 19, 114. Now, if you're struggling with that, remember we can do 6 times, 19 times 6 over here to get the 114 if you have to. So then what? Subtract it to get 3.
I'm sorry.
Then,
Bring your 2 down.
careful.
Bring your decimal up. Your decimal up.
Before we bring the 2 down, we got to move the decimal point up. Then we can bring the 2 down. So now it is 32. You're just a couple steps ahead of us.
And it goes 1.
19 goes into 32 once. And then?
Subtract that. That leaves you 13.
So 1 times 19 is 19. And we do subtract to get 13.
Add a 0 behind the 2.
Add a 0.
Bring your 0 all the way down.
Bring it down.
And then 6 times 19 is 114 again.
Okay, so 6 goes into 130. Or 19 goes into 130 6 times. 6 times 19 is 114. We subtract to get 16. Are we done? We're to the 100th.
No. Bring it, add a 0 and bring it all the way down.
One more 0, bring it down.
And then that would be an 8 at the top. 8 times
Okay.
19 would be 150.
8 times 19 is 152. So 19 goes into 168 times. So now what does that tell us?
Well, that we'd have 8 left over.
Okay.
On the bottom, but we're going to round up our 6 to 7.
Perfect. The hundredths place is right here. We needed to go that one more digit so we know, does that stay 6 or round up to 7? And as Bell said, that rounds up to a 7. So 26.17 to the nearest hundred.
My question is, the answer is 26.17. Now, if
Yep.
you added a 0 behind it, would it be wrong then? Yes.
Well,
Or would you leave
this-
it 8?
this is actually a discussion we just had in my last class. If you put a 0 back there, is it wrong? Well, is this 26.170? No.
Rounding up, it is.
If you're rounding up, it's 26.17. If you put that 0 on the end, it is implying that it actually is 170, not 16 and something else that rounded up. So no, we cannot put that 0 on the end. That would be wrong. And it's not that numerically they're equivalent, but mathematically there is a meaning to that 0 there. It is saying that we did go to the thousandths place and it's closest to 0 thousandths. Oh, no, good. It's a very good question. It's a very long discussion, though, unfortunately. Okay. Some things. The next thing I want to show you is now going back to converting between our decimals and fractions. We went from decimals into fractions. Let's go the other direction. We needed that division part to make that work. We mentioned last time, of course, there are some fractions that we just know. 3/4 is what is a decimal? 0.75. Good. But if we didn't know that one, how would we calculate it? Exactly. We said a fraction is a division problem. That is 3 divided by 4. Now on your calculator you can punch it in and get it quickly, but let's just assume you don't have a calculator. Now you might be thinking that's not a fair assumption. Well, I used to work construction engineering, and there was a lot of times I would show up on a job site. My calculator had been in the dash of my truck and got melted or dropped in the sand and some keys didn't work. Believe it or not, there are a lot of times that you get stuck and you thought you had a calculator and it's not. Or the batteries died or something silly happened. Or I sat on it or whatever. Your extra batteries for your calculator? That might be the first sign that you have a problem. Okay. Maybe a little bit dependent. So anyway, 4 goes into 3. Well, it doesn't go. So how do we handle this? I have to put in the decimal point, move the decimal point up, and then add a 0. So now 4 goes into 30 7 times. Good. 7 times 4, 28. We subtract to get 2. Add another 0 and bring it down. 4 goes into 20, 5 times, 0.75. Now the discussion always comes up, do we need the 0 in front of the decimal point? Mathematically, no. I'm going to put it in there, and I will almost always put it in there for one big reason. If it's not there, you look at that, well, is that a decimal point or is that just a stray mark on my paper? Now, well, that 0 wouldn't be there if that wasn't a decimal point, is it? In fact, if you're going into a healthcare field, I know our ADN program right now does, if you do not have that 0 in front of the decimal point, they will mark it wrong. Because anything that can be ambiguously interpreted, they don't, well, obviously in the medical field, that's bad. If your doctor prescribes 0.75 milliliters of morphine and you get 75 milliliters of morphine, it's game over. Yeah, it's more than bad. Yeah. So, well, if you want to write me a check for 75 cents and I can cash it for $75, go ahead. Yeah.
That'd be nice.
Definitely. So convert this one. Again, many of you probably know what this is a decimal, but go ahead and divide this out and convert that into a decimal, 5/8. So let's see how you did. Now, I'm going to warn you up front. I am going to make a big but very common mistake. If you see it, hold it to yourself for a while, okay? First of all, 5/8, is that bigger than 1 or smaller than 1? Smaller than 1. The numerator is smaller than the denominator, it's less than 1. So 5/8, I'm going to do 5 into 8. 5 goes into 8 once, that's 3 at the decimal point, and a 0. 5 goes into 30 6 times. 1.6, right?
No.
Well, what did I just say back here about this being less than or greater than 1? It is less than 1, smaller than 1. Does 1.6 make sense? No, it doesn't. Remember what I said about that estimating, knowing in your mind what you expect that answer to be. Just taking that second to think that's less than 1 stops this mistake. It happens way more often than you would think, especially if you're punching it in the calculator, dividing it out. I see that a lot. What should I have done? Yeah, it's not 8 divided by 5, it's 5 divided by 8. The numerator has to go on the inside. That's the number that's getting divided. So 8 goes into 5? Nothing. So 0 at the decimal point, bring it up, and then add a 0. Okay, 8 into 50. 6 times. 6 times 8 is 48. Get 2. Okay. Add a 0. Bring it down. 8 goes into 22 times. 2 times 8 is 16. Subtract to get 4. And then add a 0. Bring it down. Perfect. 8 goes into 40 exactly 5 times. There is nothing left over. So we don't even have to ask to the nearest whatever here. That just stops at the thousandth. That does not mean, however, that you can't be asked, I want this to the nearest hundredth, and you'd still have to round it off. Okay, something else I want to point out with these, and we're going to go back into a little bit of review of things like this. 3,000 times 200. There's a couple of ways we could think of this. This is 3 thousands times 2 hundreds. Combining the counts, 3 times 2 is 6. Thousands times hundreds is 100,000s. Which means that, yeah. What was our shortcut that we did?
Well, my shortcut is just take 2 times 3 is 6, count the number of zeros and add it behind 6.
Cool, that's exactly what we did for a shortcut too. 3 times 2 is 6, and we counted 1, 2, 3, 4, 5 zeros in the problem. 1, 2, 3, 4, 5 zeros in our answer. Now I did warn you that we had to be careful about problems that look like this. 200 times 50. Because what is 2 times 5? 10. Then we got 1, 2, 3 zeros. So 1, 2, does that 0 count? No, that's from the 2 and the 5. We still have to add 3 zeros to it. This is 2 hundreds times 5 tens. It makes 10. Hundreds times tens is thousands. So 10 thousands. So I'm going to turn that to look like this. 0.004 times 0.002. How did we do this? Well, a shortcut would be 2 times 4 is 8, but this is 4 thousandths, and this is 2 hundredths. 4 times 2 is 8, but what's thousandths times hundredths? 100 thousandths, right? So how many decimal places do I have to have? Tenths, hundredths, thousandths, 10 thousandths, hundredths, thousandths. My decimal point has to go there. The similarity that I'm pointing out here is we have 1, 2, 3, 4, 5 decimal places. 1, 2, 3, 4, 5 decimal places. If we scroll back up, 1, 2, 3, 4, 5 zeros. 1, 2, 3, 4, 5 zeros. Those patterns that we've talked about it all semester, those patterns are everywhere in math. As soon as you start to recognize them and put them together, that's less rules to memorize. So let's have you try this one. Talk me through it. You don't have to do this one in your notes. 4 times 5 is 20. Do I need the 0? Why? Okay. Well, it'll be obvious in a couple seconds why we need the 0. Where's my decimal point have to go? Well, how many decimal places should I have? 1, 2, 3, 4, 5, 6. The 0 had to stay here because that is one of those decimal places. 1, 2, 3, 4, 5, 6. If I drop that 0, at least at this point, it messes up my counting out my decimal places. Of course, now I could probably get rid of it and report it as that. When we were dividing with those numbers like that. Any questions so far?
Why did you drop the 0 off the book?
I didn't have to. I could have left it there. It would have been just fine. Again, that goes back to that long discussion. It depends on what we're doing with it. If it's a measurement, then we may need to leave that 0 there because it's implying some precision in the measurement. Mathematically, 0.00002 is equivalent to 0.000020. But in certain applications, like measurement and other things, it's implying a precision. That we did go to that place and it just happened to be 0 there. When you start dealing with combining them with multiplication, though, then it gets to be, it's a whole messy discussion of do you keep the 0 or not. And I don't want to get into that in here. When we were dividing numbers like this was 8 10,000ths, 10,000s I should say, and this is 4 hundreds. When we divided, we also combined the counts and combined the names. So 8 divided by 4 is 2. 10,000ths divided by hundredths was hundreds. 10,000s divided by hundreds is hundreds. And the way our shortcut for doing that, if you recall, was 8 divided by 4 is 2. Then what do we do with the zeros? We subtract them and cancel them out. There's 2 zeros left. 200. If we're dividing something like this. Now remember, technically what we would do is move this over 3 spots. This would be 4 into 1, 2, 3, 0.08. So 0.02, like that. But this same pattern exists as we had up here. 4 goes into 8 twice. There's 1, 2, 3, 4, 5 decimal places. Here's 3. 5 minus 3 is 2. 2 decimal places in our answer. Now this only works if they divide out evenly, like 8 divided by 4 is 2. So it's just a very limited shortcut. But you can see those patterns. Just like we subtract or cancel out the zeros, we can subtract or cancel out the number of decimal places. You look confused, Angie. You look confused.
Do the counting thing again?
I have 1, 2, 3, 4, 5 decimal. It's not zeros now, it's decimal places.
Oh, okay.
And then 1, 2, 3 decimal places. So I'm going to take 5 decimal places, subtract 3. I have to have 2 in my answer.
Why? And then
Well, just remember, division and multiplication are the same operation in reverse. If I multiply 0.02 times 0.004, 2 times 4 is 8, and then I add the decimal places. 1, 2, 3, 4, 5. So 1, 2, 3, 4, 5. So when I go the other direction, it would make sense that I'm subtracting the decimal places. So try that one. See what that one's going to come out to be. So what's 9 divided by 3? 3. Where's my decimal point at? How many decimal places should I have in my answer? Well, I have 1, 2, 3, 4, 5 here, right? How many here? 2. 5 minus 2 is 3. So 1, 2, 3. Now, every time I show you a shortcut, I like to show you the counter example of where it doesn't work. What's 8 divided by 5? 1.6, right? Well, this ain't going to work out very pretty at all, is it? We can't do that because this doesn't divide evenly by that. There is a way to do it, but it's kind of confusing, so I'm not going to show you. But let's go ahead and do this problem out. All we have to do is, how many spots? 3 spots, we move it over, so this is 5 going into 1, 2, 3, 0.08. So 5 cannot go into 0, so it's a 0. Bring up the decimal point. 5 into 0, 0. 5 into 8,
1.
now we can start 1. That's 5, we subtract to get 3. Add a 0, 6, perfect. 0.016. Any questions? We're going to go ahead and take our break. We're a minute early. It is now 4:19. Let's resume lecture at 4:29.